Hi everyone, thank you for joining today's webinar. So we're going to give a couple of minutes for everyone to join. In the meantime, I want to... Yeah. Hi Matteo. In the meantime, I wanted to remind you all that this webinar is going to be recorded and we're going to launch it in our YouTube channel and within our social media platforms. And I also want to remind you that we have another upcoming webinar on June 19th that is more related to topography data and to the different criteria that affect the PV plant's cost and the LCOE. Okay, I think we're good to go. We have a good number of attendees. So hi again. So today's webinar is going to be focused on a new release, so a new RatedPower software update. We're very excited to showcase this update to all of you. We call this update with this release the flexible interconnection schema, and it's an approach on how to evacuate your plant's capacity in an efficient way. Today with you, we're going to have two speakers. First, it's me. My name is Enio. I'm a senior product owner. I've been with RatedPower for the last 7 months. I'm an electrical engineer, and I've been mainly focused on power system engineering. Together with me, we have Matteo. Matteo, if you want to introduce yourself.
Hi, everyone. Welcome from my side as well. I'm Matteo Menazzi. I work as a technical advisor for RatedPower in the customer success team. For those of you who don't know what customer success does, we are the bridge between customers and salespeople. So we try to help our customers to better use PV design, and on the other hand, to bring those feedbacks back to our product team to constantly improve our software. Just one information before moving forward. During the presentation, feel free to drop any questions in the section, and then at the end, Enio and I will answer all your questions. Back to you, Enio. Thank you.
Thank you, Matteo. So jumping then to the subtopics for today. So we wanted to divide the webinar into different subtopics, starting with an introduction on what represents the new software update, the new feature, why we were so inclined to release it. Then moving on to the two very important sections, the site definition and the grid point tab and distribution strategies. We're going to show like step by step on how to define the site, what are the changes within our site definition tool, what are the different distribution strategies, and what do they represent. Afterwards, Matteo is going to bring a real life example, so a project, and it's going to draw that project within our software. We're going to jump to some conclusions, and then in the end, we're going to have a Q&A session. So jumping to the introduction. So what is flexible interconnection schema? So as you all know, it's a RatedPower update. So it's a software update, a new feature that we're going to release in our software. And the main focus of flexible interconnection schema is to remove the limitation of having just one interconnection facility in your PV plant design, and to introduce the possibility to have multiple switching and breaking stations, multiple stations and pooling substations in your evacuation scheme design. Just a small disclaimer, this feature is not released yet to production. So for all of you users of the RatedPower software, you cannot jump directly to our production and test it out. It's going to be released in the next couple of days, and we're going to launch a big marketing campaign in our social media platforms, in our website, via email. So for sure, you're going to be notified when the feature is going to be launched. So why flexible interconnection schema? What is the motivation behind it? First of all, as being part of the product, I want to emphasize that we always listen to the users' feedback, to the users and potential users' feedback, and we always want to meet the users' demand, the users' request and technical requests in order to facilitate the users' internal processes. And flexible interconnection schema, so having multiple interconnection facilities within one design, was one of the most requested features, one of the main feedbacks that we got from our users. Also, by looking at our internal statistic, over 30% of the sites that have that are drawn using RatedPower software use multiple available areas for the plant. So having just one interconnection facility is a big limitation for this type of designs. So by introducing this new release, the flexible interconnection schema, the users are now will have an enhanced way to evacuate their PV plant capacity. They can draw a new solution for the evacuation scheme, and they can have multiple types of architecture for these evacuation schemes. They can now choose a variety of facilities, so switching and breaking stations, substation, pooling substations, and they can combine each of them. In today's webinar, you're gonna see and hear a lot of keywords and a lot of acronyms maybe. So we're just gonna showcase to you what are the elements of flexible interconnection schema. So by starting with the type of facilities, we have the switching and breaking station, we have the substation and the pooling substation. So the pooling substation, the difference between the pooling substation and substation is that the pooling substation, we call just the substation that is the closest one to the point of interconnection, so the output of which is directly connected to the grid. Going on to the interconnection facilities. Sorry, I lost the presentation. So going to the interconnection schema options, we have three interconnection schema options. We have the single interconnection facility schema. So this is nothing else but the current schema that the users have up until this day. We're going to refer to this schema as L1, so level 1 schema. We have 2 levels of facility schema, which we're going to refer to during the webinar as L1, L2 facility schema. And we have 3 levels of facility schema, which we're going to refer to as L1, L2, and L3 facility schema, so with 3 levels of interconnection facilities. And by setting these grounds, we can jump to the IC section.
Thank you so much, Enio. We'll take from here. So in this section, we will look on how to create a site inside PV Design to use this new feature. First of all, what is site definition? Site definition in PV Design is the definition of that geometrical layer that we need to build up the simulation. The geometrical layer consists of available areas where we install our structure, our trackers, and also the electrical infrastructures. We have 2 ways to define this layer. The first one is to define it inside PV Design in a specific section that we call Interactive Site Creator. The second option is to upload a KMZ or KML file with all these shapes inside. Regardless the option you choose, these rules will be always the same. Now we will look in how to implement those interconnection schemas that Enio was talking about. But first of all, what is that introduced as a new part? We introduce a new polygon, the switching and breaking station polygon, SPS. You can see here in the picture that if you go to polygon, you can select the switching and breaking station. This is something new because if you remember before, you had only the possibility to define a substation polygon, And if you wanted to use a switching and breaking station, you had to change the polygon type later on in the process. Now you can select this polygon from the design phase. If you are using Google Earth, just create a new polygon and give it the SBS name. Let's now move to see the first interconnection facility schema, the so-called L1 schema. This is nothing more than the old rated power. So this is the old solution that you already know. That was very important for the team to create a solution that was built up on the existing one. So if you're interested into having just a single interconnection facility, nothing will change for you. So this facility could be a substation, and you have an example here on the left, or a switching and breaking station. As mentioned before, the only difference is that now you can already draw this SPS polygon from the beginning. So this is going to be our L1 level. And let's get a quick reminder of the main important rules. For this schema, we can only have one facility. This facility can be placed either inside or outside your available area, and it requires an MV point inside. So you need to design a point inside this polygon and call it MV. What's the purpose of this point is just to indicate the part of the facility where the MV cable is going to exit and go towards the MV field. Optionally, as you remember, we can define an overhead line connecting the facility to the point of interconnection. Here you have the view of interactive site creator. On the left side, if we use a substation, we have this purple rectangle with its MV point. On the right side, an SBS. Let's now move to the second facility schema, the two levels. So we will have a level 1 and a level 2. So this is the first new schema we are seeing today. We have two options depending on what type of facility we are selecting on level 1. So if we look on the left side, at level 1, we have switching and breaking station, and we can have more than one, actually up to 20. All these switching and breaking stations are collecting the MV line coming from the PV field. Inside the PV field, you will have over here your power stations where we convert from low voltage to medium voltage. So you go from there to your switching and breaking station, and from this switching and breaking station, we go to a single substation where we step up again the voltage from medium to high. On the right side, we see another example of a two-level schema where on level 1, we have directly some substation, so stepping up the voltage from medium to high. And then we have another substation called pooling substation by the point of interconnection with the grid. Now, remember that pooling substation and substation, they have different functions, but they are always identified by an ST polygon. Okay, so if you're drawing them, it's just an ST polygon. Okay, let's give a look to level 1. Level 1, as mentioned before, can be made of substation polygon or SBS polygon in purple and green. What are the main rules? We need, this is super important, we need to put an MV point per each L1 facility, because that's the way with which PV Design understands that that facility belongs to level 1. You can only have one type of facility at level 1, meaning you cannot mix SBS and ST polygon. You can, of course, have more than one facility at this level, but only one can overlap with a given AA polygon. But what about the connections? The connections are done automatically if you don't do anything between the AC point, which is the gate of your available area, and the MV point inside your L1 facility. Optionally, you can define an MV point inside your available area, then the connection will be between MV point and MV point. Finally, you can draw a custom MV cable connecting the available area and your L1 facility. Let's move to level 2. So this is the highest voltage level. We are by the point of interconnection. In this case, it will always be an ST polygon. That polygon will be a substation if level 1 is a switching and breaking station, or a pooling substation if level 1 is a substation. What are the rules? We can have only one facility. This is actually a universal rule. So the highest voltage level, the level by the point of interconnection, can be only one facility because we have only one injection point to the grid. Also important, no MV point required. MV point should be only at level 1. And also the connection between level 1 facilities and level 2 facility must be user defined. How can I define this connection? Now, if your level 1 is a switching and breaking station, then you can choose between MV cable and overhead line. So this is something new that we didn't have before, and it was highly requested by many customers, because for the first time you can exit our polygon with an MV cable. So that's going to be very useful for many of you. While if our level 1 is a substation, then the connection to the level 2 ST polygon, which is a pooling substation, can be done only with overhead line. Optionally, you can draw always from the level 2 facility overhead line towards the point of interconnection. Let's see a real example here under the interactive site creator. We have 2 available areas in white. We drew a SBS polygon in green for every of them. So we have 2 in total. Each of them has its own MV point. And from there, we go to a substation in purple using MV cables, which are this one in orange. From our substation, we go using an overhead line to the point of interconnection. Let's now move to the last and most complex interconnection facility schema. This is the 3 levels, L1, L2, and L3. In this case, there's only one option, which is at level 1, switching and breaking stations, collecting those MV lines from the field. From there, we go to substations at level 2, stepping up the voltage from medium to high. And finally, at level 3, we have a single pooling substation, further stepping up the voltage. As we did before, let's look at the facilities level by level. So at level 1, we have exactly the same rules as before, as the 2 levels. The only difference is that the only facility we can use is the SBS. What about the level 2 facility, also called intermediate voltage level? We can only use the ST polygon in purple, that will be a substation. And here, the main difference with the 2 levels is that we can have more than one facility. Remember not to put any MV point inside. And also the number of L2 facilities must be less than or equal to the number of L1 facilities, meaning your SBS. The idea you have to bear in mind is that we go with a pyramid distribution from the field towards the grid. So we start with a bigger layer at L1 level, we go to a smaller layer at L2, and then we end up with just one facility at L3. Also, in this case, we need to define those connections between L1 and L2 facilities, and also each L1 facility, so each SBS must connect only to a single L2 facility. Let's see what we mean. So the connection between L1 and L2 can be done between MV cables and overhead line. And like I did in this case, we can connect 2 different SBS to the same substation. What is not allowed is to take a single SBS and distribute it to 2 separate substations. Okay, that's not allowed. Let's move to the highest voltage level, our level 3, by the point of interconnection with the grid. This is going to be our pooling substation. As usual, since we are by the point of interconnection, we can only have one facility, no MV point, and mandatory user-defined connection. The connection at high voltage from substation to pooling substation can be done only with overhead lines. As usual, from your pooling substation to the point of interconnection, you can use an optional overhead line. Let's look at an example here. We have, in this case, 5 available areas. Each area has its own SBS in green. Those SBSs are collected, 2 of them in one substation over here, and 3 of them to another substation. The connection has been done using MV cables. And then from those 2 substations, we go to a pooling substation over here using overhead lines in light blue. And from our pooling substation, we go to the point of interconnection using that optional overhead line. Let's give a look now to the outputs we are getting. There are several outputs, but the most important one are grouped into a new package of documents, which will be provided as a zip file. Inside the zip file, you will find for each facility a report, a layout, and a single line diagram, and for each overhead line, a report and a layout. Later on in the presentation, I'm going to show you a quick view of some of them. I know we saw a lot of information in this section, so I want to give you some, let's say, key point to bear in mind to successfully draw this kind of connection inside PV design. So first of all, remember that the MV point always identifies the L1 facility. So MV point equals L1, all the other facilities shouldn't have an MV point. Also that the connection from L1 onwards toward your point of interconnection should always be user defined. Let's see some common problem you might bump into. You might be forgetting the MV point in the L1 polygon, or maybe you didn't connect your L1 and L2 facilities or L2 and L3. Or maybe you connected an L1 facility to two different L2 facilities. Or maybe you are mixing ST and SBS polygon at level 1. How do you know you're mixing them? Because you put MV points in both ST and SBS polygon. Or maybe you are having more than one polygon at the highest voltage level. So if you are following all the connection and you end up with two polygons, there is a mistake in your configuration. So that's all from this section. I'm gonna give the floor back to Enio to see the grid point tab and distribution strategies.
Thank you for that, Matteo. So yeah, now that we have a clear view on how to draw a project in our interactive site creator tool and how to properly set up all the polygons with each of their rules, now we're going to move on to see the grid point tab and the distribution strategies within it. So to see how this power is going to be evacuated from the PV plant and distributed within the different facilities that we draw based on the strategies that the user can select. So we're going to jump to first the design with PV plant. What do we mean by distribution strategy? So distribution strategy is an automated way for our software to decide which level 1 facilities are going to be used in your design and how how they will connect to the available area. So how these level 1 facilities are going to be connected to the available areas. The new options that we're going to introduce to the users are 3: minimize electrical losses, balance capacity distribution, and assign one facility per available area. They're pretty straightforward, so the names are self-explanatory by itself. So minimize electrical losses will always choose the path to minimize the most electrical losses. The second one, the software or the algorithm behind will try to balance the capacity between the level 1 facilities, evenly between those level 1 facilities. And third strategy will assign just one facility per each available area drawn. Within our software, you can see the screenshots on the right. In the grid point tab, in the connection type section, you're going to see a new section called distribution strategies, where the user can select each of one of the strategies. A small disclaimer, like some of the drone facilities could be discarded. So some of the facilities that were drawn using the ISC tool.
Sorry to interrupt you, but we are not seeing your screen.
Okay, now?
Okay, now yes.
Okay, perfect. Okay.
Thank you, sorry to interrupt.
No, thank you for that. Okay, so I was saying that, so I think I'm gonna go again to how does it look like. So if you can see in the grid point, I was saying we have the distribution strategies. So the users are going to select the distribution strategies in the connection type section. And the small disclaimer, as I was saying, like some of the drone facilities could be discarded. So some of the facilities that were drawn in using the ISC tool that Matteo explained before could be discarded, dependent on the strategy that the user is going to be select to distribute the capacity. Okay, jumping on to the first strategy, which is minimize electrical losses. So where the software will pick the level 1 facilities that will minimize these losses the most. In order to do that, we came up with a coefficient that we call like electrical momentum, which is nothing else by the sum of the capacity of the plant multiplied by the length of the line and divided by the square of the voltage. So by it we can have an idea of which of the paths that the user has drawn, the software can select, will have the higher losses and the lowest ones. So the software can choose the path with the lowest losses. So we can see here in this diagram, we have a PV plant with a capacity of 100 MVA. We have two paths. The first path using the ST1 station and going to the pooling substation via line 1 and line 3, and the other path highlighted in green using the ST2 station. So both of them are first level facilities, and going then with line 4 to the pooling substation. We can see here that we can simply calculate that for the path 1, we have an electrical momentum of 39/33, and for the second path, we have calculated electrical momentum of 75/68. So in this case, if the user would choose this distribution strategy, the software is going to choose the first path in order to evacuate the capacity of the plant. Now let's move to see an example of it within our software. So here you can see a design schema where you have an available area highlighted in white. You have two first level facilities, so two SBSs, so in the upper part here and the lower part, that both of them are connected to MV lines with level 2 station. So the user is going to draw this in the ISC tool. It's going to go to the grid point tab and is going to choose the minimize electrical losses option, and then the software will only choose the path that will minimize the most losses, the active losses within the two options that it had. So it's just going to use the upper SBS level 1 facility. So an exception to the rule. So if the level 1 facility sits inside the available area, the software is always going to choose that facility, even if it's going to yield to higher losses compared to the other options. So we can see here the example where we have again an available area in white, a level 1 SBS facility within that area, another level 1 facility outside, and a level 2 facility station here. So in this case, after we run the simulation, we can see here that the software chooses the SBS that sits inside the available area, even though this one might draw like lower losses than the other one. So the SBS, the level 1 facility that sits within the area, has higher priority to the one that sits outside. Moving on to the second distribution option, which is balanced capacity distribution. So by choosing this option, the software will try to distribute the power evenly between the first level facility. I want to emphasize that it will try to do that evenly. Not in all cases it will succeed to do an exact match between the two facilities, but it will always be close enough to do an even power to each facility. In order to use this option, so again we go to the ISC. The user will draw a site that has two level 1 facilities, an available area polygon, the level 2 station, and then connections between the level 1 and level 2 accordingly. The users have to choose the balanced capacity distribution option in the grid points tab, and the software will decide which MV lines to connect to which facility. So in this case, we see the difference with the minimization of losses. The software kept both of the facilities, and it connects the power stations in the available area within the plant to the level 1 facilities. Some considerations for this strategy. This is the only strategy that allows multiple different power stations from the same available area to connect to different level 1 facilities. So if we go back to the previous slide, we can see here in red, we have the power stations. So we can see we have one available area, and these power stations are connected to both level 1 facilities. So some of them are connected to the upper one, and some of them will be connected to the lower one. Another consideration is that if the number of level 1 facilities is higher than the number of MV lines, some of these facilities will be discarded. And the same kind of way as the minimization of losses option, the inner level 1 facilities have higher priority, so they are used first. Then the software will try to choose the ones that yield the lower losses. The third consideration is that if there are custom MV paths, so custom MV path we call the user-defined, user-drawn MV paths, either between two available areas or between an available area and an SBS or between an available area and a station. This software will try to respect this path. So it will try to keep in the design these custom paths drawn by the user. The third option is the assign one facility per each available area. So this option is very useful when you have designs, we have schemas where you have to collect the power of each area in a single facility and then collect them to a higher level facility. Often we've seen that these first level facilities within these schemas are internal facilities. So you can see here 4 available areas. Each one of them has an inner SBS facility, so inner first level facility. And by choosing this option, the software will connect each of these available areas to the inner facilities or to facilities that are close to the available, closer to the available areas, and then it will evacuate all of them through the second level facility. One consideration for this option, the number of level 1 facilities should be always higher or equal to the number of available areas within the design. Also, another consideration is that this option, it's not available when you have custom MV lines connecting the available areas and the level 1 facilities drawn within the design. So if the user wants to draw one custom path, it will not be able to choose this option. Okay. I hope we're clear for the PV plant distribution options. So now moving on to the distribution strategies for a hybrid plant. So for a plant that has a PV plant but also has a battery incorporating into it. So the strategies are pretty much the same. There's only one fundamental difference is that with choosing the first two options, so minimize electrical losses and the balanced capacity distribution option, the battery capacity is always going to be split into between one or more level 1 facilities, but always ensuring that each facility doesn't receive more than 70% of its own capacity coming exclusively from the battery. So these are the two only options that have this kind of rule, this kind of limitation. Using the third option, assign one facility per available area, the whole battery is going to be connected to the closest available level 1 facility. A small disclaimer here as well, there's no facility exclusively dedicated for distributing the battery capacity as for now. So we're waiting for feedback on it and we're evaluating internally if there's a need to have such facilities dedicated just to batteries. Moving on to some new features worth mentioning. So these are a couple of features that are going to be launched together with are an outcome of the new release of flexible interconnection schema. The first one being the switching and breaking station limit removal. For the current RatedPower users, you may remember that as for now, we have a limitation on on when to use SBS, the switching and breaking station. So you cannot use an SBS for capacities plants that have a capacity higher than 100 MVA or that have MV lines with a capacity with a current more than 2,100 amperes. Now this limit has been removed. We have introduced SBS containers. So now each container will have 100 MVA capacity, and one SBS area can have multiple SBS containers within the polygon, so within the facility area. And by saying that, we can jump to some real-life examples that Matteo is going to bring from the Italian market.
Perfect. Thank you so much, Enio. So jumping back to section number 4, here we wanted to show you a real example on how we can apply flexible schema to represent a real life PV plant. So this drawing you're seeing over here is taken from a real project which is going under authorization in Italy. Over here, you can see different available areas in red. In this project, they have one SBS per available area. And all those SBSs, 13 in total, are connected to a single substation. Let's zoom in a little bit. The substation is over here. Let me get the laser. So here we have a substation which is collecting this power. This substation is stepping up the voltage from 30 to 150 kV. And then there is a single connection going to a pooling substation with a voltage from 150 to 380 kV. So what we did was recreate the exact same interconnection schema in PV design. So as you saw over here, we basically created several available areas. We put an SBS per each in green. We connected all of them using MV cables. We put a substation here and a pooling substation over here. So we recreated exactly the same diagram. Then what can we get as a result? As promised, let's start from the field. So the first thing you're gonna see is your SBS in here. So this is just one area, and this is one of the 13 SBSs that we have. So the SBS represented in the layout corresponds to this drawing over here in your single line diagram. As you can see in the field, we have 18 power stations that are here in red, connected into 2 MV lines, 1 and 2, that are going into 2 MV cubicles of this SBS. And then we have a single MV line, medium voltage line, which is going from the switching and breaking station to the substation. So now let's move to the substation SLD. So in this case, just one substation. As you can see on the bottom, we have 13 incoming MV lines from those 13 SBSs that are collecting the power at medium voltage. And then we have 2 transformer bays stepping up the voltage from 30 to 150 kV. Finally, we have one single high voltage line going towards my pooling substation. So this is your pooling substation's SLD. On the bottom, you have that incoming line from your substation and one transformer stepping up the voltage from 150 to 380 kV. So that's it. I know, a little bit quick, but we don't have that much time, so I'm gonna give it back to Enio for the conclusions.
Thank you for that, Matteo. So jumping on to some conclusions, I hope it was clear for you, the new updates that we're releasing in our software. So the main conclusion is that we are introducing multiple layers of interconnection facilities within our software. So we're removing the limit that we currently have of just having one interconnection facility. We are also enhancing the flexibility for our users to draw the evacuation solution schemes and to have new architectures for their evacuation schemes. And we're also optimizing the connection between the PV plant and the facilities based on the required strategy that the user is going to choose within our software. So by saying that, we can jump, I think, to the Q&A section. I see that we have quite a long.
I can, if you want, Enio, I can start answering some. We have a lot of them, so thank you so much, all of you, for really participating in this webinar. So the first one I want to answer is they are asking what is the MV meaning. Sorry for that, I didn't explain the acronym. It means medium voltage, and HV high voltage. Another recurrent question, Enio, we got was about the underground cables for high voltage. Since you're working on that, maybe you can take that question.
Yeah, I'm proud to say that we are really working on that. It's actually one of our highest priorities internally. So we're currently working internally to provide the best solution possible for you to define an underground cable, even for higher voltages, up to 500 kV, which we have the same for NoHL. So I see a lot of questions about that, and we've also had a lot of feedbacks from our users. So we're going to launch it soon. As I said, we have on top of our priority list.
All right. Another question maybe I can take. So can I select 2 or more available areas grouped in low voltage for SBS? So this is, thank you for the question, first of all. The low voltage grouping is a functionality we have inside PV Design, for those of you who don't know it, that basically allows us to group 2 areas to share basically the same power station, to put it simple. So this user is asking if you can group this area in low voltage, so let them share a power station and then evacuate the power of this group to a single SBS, and the answer is yes, that is possible.
Perfect. I think I can get another question that is regarding the power factor requirement. So we have a question saying, will the power factor requirements be possible to be defined for L2, L3, or even point of interconnection? And the answer is yes. You can define the point of measurements wherever you want within the schema, and you can then define the required power factor for that measurement point using the slider in our grid point tab in the grid requirements section, and it will calculate then the power factor in the inverters, and you can use different strategies the same way you are using it as for the current software.
Thank you, Enio. So I'll take another one in the meanwhile. So we have 2 questions by the same user. Will it be possible to have a pooling substation without transformer? So that's the first question, and the answer is not for now, because the SBS is the only facility we have without transformers. Substation and pooling substation, they always have transformer for now, but feel free to reach out to us, to support, to give us, like the reason why you would need something like that, and the team will be more than happy to look into it. The second question we got from the same user is, will it be possible to define the point of interconnection as a point? So if I understand it correctly, when you draw that optional outgoing line, do you remember the overhead line from your last facility to the point of interconnection? That will be actually a point because it's just taken as the end of that line. Hopefully I got the question right.
I really see a lot of questions and requests for underground cables, so that is conforming from our side. So that enforces our idea to have that release as soon as possible.
Yeah, I can take another one in the meanwhile if you want. This user is asking, what happens if we make a mistake with this configuration? Does the system tell us about the error? How? So the error that you can make are most of them when you are defining your site. So the second section that we saw together, in the first one I explained. In that section, if you have any kind of error, PV Design is gonna tell you there is some kind of problem. It's not always super easy for the software to understand, to tell you exactly where is the problem, because you could have a very complex architecture, but there is always a message telling you, look into this or look into that. But if you keep those rules in mind, you shouldn't have any problem. And of course, feel free to reach out to us if you, of course, you cannot fix the problem.
Okay. I think we have another question that says, how are the circuit impedances being calculated in the software automatically? I guess that is a long topic for us to answer now within the Q&A, but I would recommend you to check our methodologies in our website, where we have all the calculation or the formulas used for us to calculate the impedances internally. We can send you those the link to the methodologies after the webinar.
Can we have more than one name?
Also, we have another question that says, this we answered, is I saw a question saying that how can we check which power stations are connected to which level 1 facility? And I would say that the best way to do that would be either to our DXF output, so the AutoCAD output, or one of our other outputs, one of our SLDs.
All right, let me take another question from one of my customers. Thank you for the question. First of all, he's asking, why can't we have more than one available area for each L1 switching and breaking station? If I have a lot of areas and I want to collect into some SBS, I think it will be very useful. Maybe I didn't understand well. Yeah, actually, probably I didn't explain it very clearly. That is possible. So you can have more than one AA and like collect 4 AAs into a single switching and breaking station. That's totally fine. So it's not a problem. The only limitation is when you go from an SBS to an ST, that you cannot do the other way around, like one SBS split into 2 ST. But from a lot of AAs to go to a single SBS, that is possible.
Okay. I guess we're right on point with time, Matteo.
Yeah, there are a couple of questions we didn't answer. We will reply by email to those of you that we didn't have the time to answer.
Thank you, everyone. I hope it was informative, and we'll notify you as soon as we launch our new feature.
Thanks, everyone, for joining. Have a good rest of the day.
Bye-bye.
Bye.